Here we see the cockpit of the Corsair. The fuselage is heavily colonized by marine life, a stark contrast to its wartime purpose.
Hidden for decades, the wreck of the Silver Star is finally found. And now, reborn through advanced technology, it flies once more.
The landing gear, remarkably intact, tells a story of a sudden descent. The chains here suggest
The Hinokaru, the rising sun emblem, clearly visible on the tail fin. This zero remained hidden for nearly 8 decades.
The vibrant clownfish finds sanctuary in the unlikeliest of places, a rusting relic of a bygone era, deep beneath the waves.
Alright, moving into the engine now. Shining the light inside. Check the turbines for damage.
Decades underwater, the fuselage is now home to thousands of fish, a testament to nature's resilience.
Using the high-pressure jet, we can clear decades of silt and marine growth, finally revealing the cockpit controls underneath.
As the canopy yields, a flurry of damselfish escapes the darkness. The interior is a stark contrast of
Using the specialized underwater impact driver, the diver secures the heavy chains around the F-15's landing gear, preparing the wreckage for recovery.
Here we see the dual challenge of the salvage operation. The impact driver frees the chains, while the water jet clears the landing gear.
Lifting a wreck of this size always disturbs the seabed. The challenge now is maintaining visibility through the dense silt.
Tower, we have a positive lift. Roger that, proceed to base.
The heavy-lift helicopter successfully hoisted the downed fighter jet, a critical step in the deep-sea recovery operation.
Maintain your hover. Coming down slowly now, 5 feet. Clear to land, left side clear. Cut.
Easy. Bring it down another 2 feet. Roger that, coming down slow, watch the tail section.
Starting the tug now, all clear around the aircraft.
After securing the tow bar to the landing gear, the final step is connecting it to the yellow tug.
All right, moving to the next segment now. The hydroblaster is really cutting through that growth.
All right, that should do it for the upper section. Now for the lower starboard side.
Almost got this section clear. Moving to the next panel now.
These aren't just cosmetic. If left untreated, the barnacles can disrupt airflow and compromise the stealth coating.
Barnacles and thick marine sludge are no match for the pressurized water stream, a crucial step in aircraft maintenance.
We use about 40,000 PSI to get through this level of calcification. It's tough on the arms, but satisfying work.
This pressure setting is ideal for the cockpit glass. Any higher and you risk etching the surface. We move in smooth, overlapping passes like this.
The high-pressure stream is essential for removing the stubborn incrustation, ensuring the fighter jet maintains peak performance.
We're using about 4,000 PSI here. You can see how the water shears the dirt right off the low observable coating.
The specialized foam is crucial for deep cleaning, clinging to the fuselage and lifting contaminants without damaging the sensitive stealth coating.
We use this foam to decontaminate the surface before the full washdown.
The specialized foam is essential for removing hydraulic fluid residue without damaging the stealth coating.
Maintaining these jets requires meticulous cleaning protocols, utilizing high-pressure systems to strip away the thick decontaminant foam.
All right, move to the starboard side now. Copy. Watch the spray near the canopy. We use a specialized foam solution first, let it sit for a few minutes, and then hit it with the high-pressure wash.
The buildup of grime on the landing gear requires a specialized high-pressure wash to ensure structural integrity checks can be performed.
The landing gear requires meticulous cleaning to ensure there are no hairline fractures or corrosion before the next flight.
All right, right, almost got it. There we go. That was stubborn.
The biggest challenge with these older models is getting the initial panels off without compromising the fuselage. Everything is rusted solid.
Okay, that finally broke free. These older models really put up a fight. Now for the hard part, getting it out.
Removing the seats is heavy work, but crucial for accessing the fuselage wiring.
The first step is always the hardest. Corroded wiring harnesses require immense pressure before we can access the avionics panel underneath.
Watch the hydraulics, it's coming loose. Okay, I'm clear. Taking the hammer to the seat frame now. All right, come on, just a little more. Got it.
Finally got it. Man, that thing was really on there. Look at this mess.
Every component must be meticulously cleaned. It's grueling work, but essential for these old birds to fly again.
It takes some force to get this open. Now, looking inside, this bundle right here is the primary concern for the inspection.
We have to make sure the tolerances are perfect here, otherwise the structural integrity is compromised.
This part of the turbine needs absolute precision. The grinder allows us to smooth out the edges.
The tolerances here are extremely tight. It requires significant leverage to ensure a perfect seal.
Hoisting this massive relic is no small feat. As you can see, the years of rust are simply cascading onto the hangar floor below.
Torque check complete on the high pressure turbine. It's within tolerance.
Easy now. Get it seated. Okay, let's see if we can crack this open.
Moving the components requires precision and strength. The next phase involves a detailed inspection of the engine itself.
From the flight deck instrumentation to the smallest component in the hangar, attention to detail is paramount for safety.
Watch the clearance on the left side, keep it steady.
Here we see the machined parts entering the ultrasonic bath. The green solution reacts instantly, lifting contaminants from the delicate surfaces.
Here we see the automated crane system lowering the components into the heated aqueous cleaning solution.
Once the basket is fully submerged, the ultrasonic agitation begins, ensuring every component is perfectly clean before coating.
We use about 3,000 PSI on these baskets to get the initial grease off before moving to the larger components.
We have to be very careful loading these titanium parts, ensuring they are secure before the wash cycle begins.
I'm applying the gray primer now, making sure the strokes overlap by at least 50% to get that smooth finish.
The key here is overlapping the previous stroke by about 50% to ensure a seamless finish on the leading edge.
Look at that shine. The surface integrity is flawless.
Reverie. The pneumatic impact wrench delivers precise, high-speed torque, essential for securing the main landing gear.
Critical bolt secured. We are good to proceed to the next step.
You have to lift it just right to clear the strut. Once it's seated, we grab the torque wrench and tighten the retaining nut to specification.
The installation of the cylindrical component requires careful handling and precise drilling to ensure it's fully secured before flight.
Precision is everything when you're dealing with the main strut. The cordless impact wrench makes this job much faster, ensuring the bolts are secured to the precise specifications. We're applying 250 foot-pounds here. You wait for the click, just like that. Now we verify the setting. We use the hydraulic ratchet for the main actuator bolt here, ensuring it meets the exact specifications before we can clear it for flight. We use the impact wrench here to secure the main landing gear bolts to the specified torque.
And with the final confirmation, the F-35's landing gear locks into position, ready for inspection.
All right, easy now. Bring it down another foot and hold it steady. Watch your clearance on the starboard side. Okay, we are clear. Keep it steady. Down a few inches. Watch the alignment on the forward mounts. Okay, stop the descent. We are good to go.
Securing the fan hub requires precision and power, ensuring the engine can withstand the extreme forces of flight.
All right, steady pressure now. Waiting for the click. There we go, 500 foot-pounds.
This torque wrench ensures the bolts are secured to exact specifications. Safety is paramount.
Removing this turbine is a delicate process. One wrong move and the whole thing could be compromised.
Once the pliers lock into place, the connection is secure. Always double-check the fitting before moving on to the next line.
The temperature delta is within acceptable parameters. We are good to proceed with the stage 1 checks. All right, panel 7 is secure. Always check the tension on these final latches before moving on to the next section.
You have to ensure the coupling is perfectly aligned before applying the final torque. Otherwise, you risk a leak under pressure.
The silver radiator, a critical piece for the thermal system, must be carefully maneuvered into the main housing. Now we secure the final latches.
Once the tie is threaded, we pull it snug by hand. Then the tensioner applies the final calibrated squeeze and snips the excess flush. Align the pins carefully, push until it seats, and then twist the locking ring clockwise until you hear the final click.
All right, you want to make sure these panels are flush before you secure the screws. The torque setting is critical here.
The main avionics panel requires absolute precision during installation, ensuring every connector seats perfectly before the final securing sequence.
This harness controls the primary avionics bus. We have to ensure every crimp is perfect before we secure the bundle.
Match the colors precisely. Red goes here, followed by the blue connector, then the yellow, and finally the green. Ensure a snug fit on all of them.
The final piece of the avionics suite, the primary flight display, slides securely into the center console.
The final step is securing the rudder pedals using the socket wrench to the specified tension.
All right, that's better. Now, the key here is to align the base perfectly before securing the bolts. It has to be precise.
We slide the grip onto the column, making sure the pins engage smoothly before tightening the collar.
Ensuring the flight stick is secure is the first step.
The team then moves outside to meticulously check the fuselage panels and wiring before takeoff.
Torque settings confirmed on panel 5. All green here.
Initiating full range of motion test. Ailerons responding within tolerance.
Flight stick calibration is complete. All systems green across the board.
Looks good. This seat is ready for installation, Captain.
Okay, that's locked in. Roger that. Securing the first bolt now.
How's that seat install coming along back there? Just finished the final adjustment. Solid as a rock.
You want to ensure the connectors are fully engaged before applying pressure. Listen for that distinct click, then check the flushness along the edge.
We have to make sure these connections are absolutely secure before the next flight.
Wiring connected. The landing light is fully operational and ready for deployment, sir.
And that's the final torque setting for the starboard engine nozzle. Confirmed green on the gauge.
All right, that's 300 inch-pounds.
Always listen for the click when securing the panel bolts. This section here, near the radomi, requires the most attention. We can't miss a spot before the next flight check. Maintaining the nose cone is precise work. We make sure every inch is perfect before takeoff.
This is the culmination of years of hard work. She's ready for the skies.
The final visual inspection is critical. We move section by section, ensuring every rivet and panel is secure before rollout.
Power systems engaged, avionics online, throttle check complete, all indicators green.
Initiating the start sequence now. The turbine begins its rapid acceleration towards idle.
The canopy alone weighs over 400 pounds, but the hydraulics make the closure smooth and secure.
A spectacular sight here at the airfield today as Captain Rodriguez taxis the F-22 Raptor past the cheering spectators.
The MiG-29, recognizable by its distinctive red star insignia, engages afterburner for a rapid ascent. The MiG, recognized by its distinctive dorsal intake, begins a sharp, evasive maneuver. The aircraft initiates the maneuver, climbing vertically before executing a perfect loop-the-loop, leaving a distinctive smoke trail against the blue sky.
Centrifuge engaged. Bank angle steady. Acknowledged. Viper 1. Maintain bearing.
This advanced delta wing design allows for incredible speed and maneuverability at high altitudes. The pilot executes a perfect barrel roll, demonstrating the incredible agility of this machine against the glare of the sun. The black smoke billowing from the engine suggests a critical failure, yet the pilot maintains course directly towards the fleet.
The F-22 executes a dramatic bang, showcasing its superior agility against the vibrant landscape below.
The jet initiates a slow, controlled roll, revealing the intricate details of its underside, and the substantial...
Ascending rapidly, the jet burns fuel to create the spectacular smoke trail, perfectly centering the sun.
All right, bring it down slow.
Roger that, coming down.
Watch the alignment on the starboard side. A little to the left. Perfect, lock it down. These hoses are critical for the landing gear hydraulics. We use the specialized torque wrench to ensure it's secured precisely to the manufacturer's specification.
We use the cordless drill for the initial fasteners, making sure the alignment is perfect before the final riveting.
Now we secure the fittings. These are the primary cooling lines for the forward array.
Once the floor panels are secure, we start routing the main electrical bundles along the interior structure, making sure they're neatly tied down.
Confirmed green on all 3 displays. System check initiated.
Red is secure. Now for the blue one. Got to make sure the seating is perfect before the final inspection.
Once the flight control stick is properly torqued and tested, the pilot's seat can be slid onto the rails and locked securely into position.